Okay, so we're going to kind of tie this all together now into what's called limiting reagent calculation. So hopefully you just looked at the simulation online for limiting reagents and you have kind of a conceptual idea of what these things are. We're going to go ahead and work on some calculations dealing with them now. But a limiting reagent or a reactant is a substance that's totally consumed during a chemical reaction. It's going to limit the amount of product that forms because it's going to run out first, but it's not necessarily the reactant present in the smallest amount. For example, if I tell you have 2 grams of something and 5 grams of something else that react, it's not necessarily the 2 grams. So you need to do some calculations. So some steps we're going to do, we're going to calculate the amount of moles of product formed based off of the amounts of one reactant, do the same thing for the other reactant then we're going to compare them to find the limiting reagent. So when we go ahead and look at this first problem here, it says if 37 grams of aluminum sulfate react with 52 grams of barium nitrate, what's limiting reagent, how many moles of aluminum nitrate can form, and how much excess reagent is left over. So as you can kind of see here, there's a lot involved in these problems, so we're going to start taking them step by step. So first step, like we have been saying, we first need to make sure we have a balanced reaction. So this reaction that we have here is written for us, but we need to make sure it's balanced. So if I look here right away, I see 2 aluminums and 1. So that's going to be a problem. So I'm going to try to combat that issue here with the 2 right here. Okay, now I'm going to go ahead and look. Sulfates, I have 3 of them here and only 1 of them here. So I'm going to go ahead and put a 3 right here. That means I need 3 bariums. And then my first value here, aluminum sulfate, is good. So first thing I'm going to do is I'm going to do kind of 2 conversions, one with each substance. So let's start with the first thing we're given in the problem, this 37 grams of aluminum sulfate. So I'm just going to start down here and we're going to start with that number. So we have 37 grams of Al2SO4 All right, now whatever again is up here needs to come down. So if we have grams of aluminum sulfate up here, we need grams of aluminum sulfate down here. If you were to add up 2 aluminums, 3 sulfurs, and 12 oxygens, you should get a molar mass of 342.2 grams. Okay, and that's in 1 mole of aluminum. Okay, now we need to go ahead and convert that into moles of product, essentially. So what we're going to do is we're going to just pick one of them. I'm just going to pick the aluminum nitrate. Doesn't matter as long as you compare the same one, okay? So up here, there's a 1 in front of aluminum sulfate. So 1 mole of aluminum sulfate is going to go here. Then I'm going to pick this one, so 2 moles of aluminum nitrate is going to go here. Okay, I'm going to go ahead and calculate this, so I'm left with moles of aluminum nitrate. When you go ahead and multiply and divide that out, you're going to get 0.2162, and this is moles of aluminum nitrate. All right, now we need to do the exact same thing from the other reactant given. So we're given 52 grams of barium nitrate. So same thing, molar mass is going to go down here. If you add that up, you should get around 261.33 grams. And that's in 1 mole of barium nitrate. All right, so this should actually be a 2, my apologies, and this should be a 2 here as well. Okay, so we're going to go ahead and keep multiplying that out. We're going to get from moles of barium nitrate into moles of aluminum nitrate, just like up here. So same thing up top, 2 moles of aluminum. On the bottom, if we look up here, we got 3 moles of barium nitrate, so 3 moles of barium nitrate. Go ahead and calculate this out. What we're looking at here is we are looking at 0.133 moles of aluminum nitrate. Okay, so next thing we need to do is we need to decide which of these 2 values would be smaller. So if we look at these, we have this number here, 0.2162, and this number here is 0.133. So if we go ahead and decide which one of those 2 values is smaller, that'd be this one, okay? Which means that this reactant will run out when we hit 0.133 moles of aluminum nitrate. This one could keep going until we get to 0.2162 moles, but this one will be all gone, so it can't continue to go there. So that means because this creates the smaller of the 2 numbers, I look back here and say, oh, well, this is the reactant that's going to run out first. this is going to become our limiting reactant or reagent. So I'm just going to write that down here so we have it. I'm just going to abbreviate that, and you'll see me do this all year. So limiting reagent, I'm just going to write LR, is barium nitrate in this case. Okay. Now, we're not done with this problem. We did the first two parts, the limiting reagent, and we know how many moles of aluminum nitrate can form. That would be this amount right here. Okay. Now, how much excess reagent is left over is a little different. So what we're going to do is we're basically going to figure out, well, how much in terms of moles of this could we have left? And we're going to take that as basically a proportion of what we started with. So to write this out here, I'm going to write down here that our excess reagent is going to be the other one that's left. So that's going to be the Al2SO4 3, the aluminum sulfate. What I'm going to do is subtract these two mole values. So 0.2162, so 0.2162 moles minus the other one. Then what we're going to do is we're going to go ahead and divide that by what we started with to find a proportion of what's left. So we're going to start with this value here, the 0.2162 moles, because that's how much we could in theory make, but we're going to say, okay, well, we used up this much of it, so how much do we have left in terms of proportion of what we could make? We're going to multiply that by the mass that we started with. So if we go ahead and subtract, divide out, multiply by the mass, that means that we can find out how much we have left over. So that's going to be now in grams, because these moles will cancel. So we have 14.24 grams left over. Okay. You can also do this kind of conversion with bridges. So we can do this with a dimensional analysis calculation. That one takes a lot longer and it's more work. So this is kind of the shortcut method.